All right, so two simple problems, right? All the hard stuff's done. It's already factored. Your job is, solve. And so when you solve, you get x is equal to 1 and x is equal to -3. Okay? Same thing over here. Solve this, I'll get x is equal to 2 and x is equal to 8. There's no x associated with that 1/2, so it doesn't generate an answer. So we got our two answers. All right. So why would I ask this, right? What does this have to do with what I talked about yesterday? So like yesterday, we talked, the main purpose of yesterday was graphing parabolas. We talked about finding the vertex, and then, in the last few problems, you actually had to plot points, come up with a parabola. This I'm just asking you to solve. So what does this have to do with graphing parabolas? Well, these aren't the original questions. See, the original questions are, what is the graph of y equals x minus 1 times x plus 3? Because this is an equation, so you solve an equation, but what we were doing yesterday was graphing quadratics. And there's actually a couple of problems where they were already factored and you had to graph. And the way we had to do this yesterday was, okay, find the vertex. So that means, multiply it out, do the negative b over 2a, plug it in to find the y value, and graph there. Today we're going to talk about another way of graphing, particularly if it looks like this. And to be honest, I actually like this, graphing these, better than stuff with vertex form. So how do we go about doing it? Well, let's see, I need some graph paper. So I'll go up here. And our goal is, I want to graph this equation. All right? So how do we go about it? Well, we will need the vertex, but whenever it looks like this, you don't find the vertex first. You find the intercepts first. So we're going to talk about how do you find, I want to find the x-intercepts, and then I want to find the y-intercept. So how do you find x and y-intercepts? Well, anytime you're looking for intercepts, you're going to plug 0 in for something. And it turns out, if I plug 0 in for y, that's going to give me 0 is equal to x minus 1 times x plus 3. To solve this equation is exactly what I made you do 2 minutes ago. Yeah, 2 minutes ago, all right? And when you solve, so what you found when you did when you solved that original equation is you found the x-intercepts. How do I know that they're x-intercepts? Well, it's the only letter that's left. So what I have is I know my x-intercepts are at 1 and -3. Okay? What does that mean in your picture? Well, this is the x-axis, this is the y-axis. If you have x-intercepts at 1 and -3, that means this parabola is going to cross the x-axis at 1 and at -3. Right? So when we solved, we had this thing equals 0, and we found the two x values. What we found are the two dots where the graph crosses. All right, next up, I want to find the y-intercept. And the way we're going to find the y-intercept is we're going to plug in 0 for the other thing. And so if I plug in 0 for x's, that's not so bad. When I plug in 0 for x's, then that's going to give me y equals, well, a -1 times 3. And so I end up with y is equal to -3. So I just found out that my y-intercept is going to be -3. And if we're keeping track of, as far as our picture goes, that means it's going to cross the y-axis at -3.
Sorry, can you repeat that for y? Why is it -1 times 3?
Because we plugged in 0 for x. So think of this as 0 minus 1 and a 0 plus 3. And so 0 minus 1 gives you -1, and the 0 plus 3 gives you 3. Now, officially, when you have to write this down on a quiz or a test, you just can't say x-intercepts at 1 and 3. You have to give me the coordinate. So you'd actually, more space. If your x-intercept is 1, that's actually the coordinate 1, 0. And instead of -3, you'd say that's the coordinate -3, 0. And as far as my y-intercept goes, I would say that instead of just saying -3, you have to say it's the coordinate 0, -3. All right, so let's talk. Because what I've got is 3 dots, and I still need to graph, right? And it wasn't hard to come up with those 3 dots. It just had to do, we plugged in 0, we solved. And you can kind of look at this, and you say, well, I guess the parabola is probably going to look something like this. Right? Now, to graph the parabola, you still need the vertex. That's the most important part of any parabola is the vertex. So you still have to find the vertex. So, how do you do that? Well, let's talk about what we know about a parabola. See, what we know about a parabola is, and this is just me drawing, what we know about a parabola is it's symmetric, meaning whatever's on the left and whatever's on the right. So if I give you 2 dots, well, what we know about the vertex is that it's on the axis of symmetry. It's on that line that cuts the parabola in half. Right? That's what we know. Well, here's what we have. We have 2 dots, our x-intercepts. Our axis of symmetry is going to be exactly in between those 2 x-intercepts. So I want you to imagine that we have a line that cuts down the middle. And you can find it lots of ways. Right now we're just going to say, hey, look, there's 4 spaces in between, so I'm going to go 2 spaces, and I'm going to put my axis of symmetry. See how it cuts exactly in half. So I'm going to write that over here. So axis of symmetry, and that's going to be x is equal to -1. All right. Actually, let me move this over so we can see more of this. Now, we still need our vertex. And how we find our vertex is actually going to be kind of like how we found the vertex yesterday. A vertex has an x part and has a y part. The x part is your axis of symmetry. So in this case, our x part is -1. Our y part is going to be the, let's see, and how we find the y part is exactly how we found it yesterday. Remember how when we found our vertex, we did the -b over 2a, found the x, and we had to plug it back into the function to figure out the y? Well, that's exactly what we're going to do. We just found out that our x part was -1. So to figure out the y part, we're going to go back to our original function, and we're going to plug -1 in for x. So we're going to have a -1, and then we'll have a -1 plus 3. And here I'll do color coded. So here's the original function, and I plug -1 in for the x. And so now I work it out, and I get, let's see, -2, and that's going to give me a +2, so I end up with y is equal to a -4. So I just found out that my vertex is at -1, 4. So if you go -1 down 4, I know that's my vertex. And let's see, I know this dot and this dot are the same. If I have a dot over here, that means I have a dot over here.
Do you mean -4 or 4 for the?
-4.
Okay.
Yeah. And so now I've got all my dots, and I've got my nice little picture of a parabola. Now, so let's recap what I just did. We started with a parabola that's in factored form. When it's in factored form, it was really easy to find out what our x and y intercepts were. And so we found those first. Once we found our x and y intercepts, we kind of plotted them on our graph so we get an idea what things are going to look like. To graph the parabola, we need our vertex. So how do you find your vertex? Well, the way we find the vertex is similar to what we did yesterday. You found the x part first and then plugged that in to find the y part. How do you find the x part? The x part is going to be that line that's your axis of symmetry that cuts everything in half. And so you find that that's going to be in between the 2 x-intercepts. Once you find the x value, then you plug that x value back into your function to find your y. And that gives you your vertex. And once you plot that, then you've got your picture. All right? So let's try it again. we're going to try it again with this function, y equals negative 1/2 x minus 2 times x minus 8. And this was the second problem from what we started class with. So what I want everyone to do is I want you to find your x and y intercepts, plot them, and then do the electronic hand race so I can kind of see where everybody is. And I'm going to press pause. Okay. So we have a dot. Yeah, you can kind of see those. We got a dot here, we have a dot here, we have a dot here. And hopefully it doesn't take too much to realize we're going to have a parabola that does something like this. And that should kind of make sense because if you've got a negative in front, that means the parabola's been flipped. Remember, positive in front, you got a happy parabola, negative, you got a sad parabola. All right, so we're still missing the most important part, which is our vertex. So our vertex is going to be your axis of symmetry. And you find that's going to be in between the two x-intercepts. How do you find it? Well, you could just sort of count. You go, okay, there's 6 spaces, so I go 3 in the way. The axis of symmetry is going to be 3 units in the middle. The other is, it's simply the average of your x-intercepts. So if you do 2 plus 8 divided by 2, it gives you 5. Our axis of symmetry is going to be x equals 5. So I end up with, this is our middle line. And now that I have my axis of symmetry, I can find my vertex. And how I find my vertex is I'm going to plug this x value into the function, because that's how you find your y value. That's how we did it yesterday. Like, you found out what x was, and once you found out what x was, you plug it back into the function, and then that's going to tell you what your y value is. So, let's see, if I plug 5 back into my function, this is going to give me negative 1/2, 3, and negative 3. So it looks like I'm going to get 9 over 2. So that means my vertex is going to be 5, 9 over 2. So 9 over 2, that's about 4.5. So there's 4.5, there's my dot. And if I look at this, it's like I get a parabola that goes down here. If I get a dot on this side of the parabola, I should be able to get a dot on the other side of the parabola. So if you think about, this dot is 1, 2, 3, 4, 5 away. I'm going to go 1, 2, 3, 4, 5 away and put a dot. And here's my other spot of the parabola. And I've graphed it. Right? So what was important about all this? Well, what you do is your main goal is find the intercepts, and then use what you know about intercepts to find out where your vertex is. Because we've got we found our intercepts, and the y-intercept's helpful, but the x-intercepts is what really helps us. Then we find our axis of symmetry. That gives us the x part of our vertex. Once we know the x part of our vertex, we plug it into the function to find our y part. And then we've got enough points to come up with a pretty good picture of what the parabola looks like. So, problem 1 worked exactly like the others. Your job was find the x-intercepts. You can use that information to help you figure out your axis of symmetry, which gives you the x part of your vertex. Plug that in to find the y part of your vertex. So that gives you kind of your peak or your valley. Find the y-intercept, it gives you one more point, then do the sort of a symmetry part, get you another dot on the other side of the parabola. Then connect your dots. Okay? And these first 6 problems all work that way. But I'm a little more interested in the next 6. So I want everybody to scroll down and look at problem 7. All right, so what happens in problem 7? We're going backwards. See, usually what happens in math is you learn how to do something forwards, And after you get used to doing it forwards, they make you go backwards, and that's exactly what's happening here. And normally what happens going backwards is it being harder than going forwards. In general, there is, like yesterday we talked about the standard form, the vertex form. It had like an H and a K and an A. The same thing happens here. They have it's called intercept form. Actually, let me go back up and talk about why it's called the intercept form. So this is called the intercept form, and the reason it's called the intercept form is it's very easy to find the intercepts, like -4 and 2. The reason yesterday's version was called vertex forms is it's very easy to find the vertex. Right? We're not creative when they name, math people are not creative when they name things. So the general intercept form looks like this. Well, actually I should probably have this up here. It's y equals some number a, x minus p, x minus q. Where a is some number that we typically have to find, and p and q represent the intercepts. And if you look, in this, like the problem we just did, the a was 1/2. They have the p as a 4 and the q as a 2. Okay? Actually, I have the q as a 2 and the p ends up being a -4, but I'm going to talk about that when we practice the next problem. So when we look at problem 7, where we've got a nice picture, our job is to figure out, what goes here. Well, if you look at problem 7, these things, it says what's p and what's q. Well, when it asks what's p and what's q, it's really asking you what are your x-intercepts. So when I look at this, I've got an x-intercept of -2 and I have an x-intercept of 3. So p is going to be -2 and q is going to be 3. How did I get the p and the q? I got it from wherever it crossed the x-axis. The next thing it has, and the person I got this from, I think they're being a little redundant with it, but we're going to use it. They ask x and y equals. The way you solve, actually, we're going to come back to that. So our job is to find the equation. If our job is to find the equation, remember we got to know what p and q are. We need to know what our x-intercepts are. In this problem, what we end up with, I'm going to write it in a different color, is y equals, let's see, if I need a -2 as an x-intercept, I'm going to put an x plus 2 as a factor. If I need a 3 as an x-intercept, I'm going to say x minus 3. So if I know my x-intercepts, I can write this part of my equation not too difficultly. I mean, it's just you make sure that this factor gives you this value and this factor gives you this value. What we're missing is the number in front. And how you find that number in front is you need another point. And they give you that point. See, when they give you this point, they're telling you, when you plug in x, you better get -12 for y. That's what this says. Anytime you have a dot on a graph, it's saying when you plug this in for x, this value in for x, you have to get that value out for y. And so this particular worksheet is saying, they're rolling an x and a y, they basically want you to write down what's the x and y value of the point they give you. And the point they give you here is 2 and -12. So how does that help you? Well, if we've got an equation, this says if I plug 2 in for all the x's and a -12 for the y, then I can solve for a. So I'm going to plug in 2 for the x's, so this is going to give me 2 plus 2, and then 2 minus 3, and there's an a. And I'm going to plug in -12 for the y, because that's what we have to do. To find the a, you've got to plug your point in. And so now when I plug this in, I end up with a -12. Let's say that's a 4, a -1, and an a. So I get -12 is equal to a -4a. And now it's easy to solve. So I end up with a is equal to -3. So if a equals -3, I've got my equation. All right, so recap, how do we do these? The first thing you do with a picture is you want to identify your x-intercepts. And they're pretty obvious here. They tell you, you cross here and here. After you identify your x-intercepts, then you plug, that's your P and your Q, you plug those into the formula to get an x minus something or an x plus something. It gives you kind of your factors. The last thing you have to find is the A. And the way you find the A value is you've got, they always give you a dot. And so you...
Shouldn't it be positive 3?
Yes, should be positive 3. Sorry. I'm having a tough time breathing through this thing. And so once we have our, so we plug the value in, then we can find our A. So what I want everyone to do is I want everybody to do problem 8. And then once you get problem 8, you want to identify your P and your Q. In this case, your P and your Q are 2 and 4. So I'll have a 2 and a 4. So I know my equation is going to be y is equal to x minus 2, x minus 4, and I need to figure out what the A is. How I'm going to figure out what the A is they give me a dot. In this case, my dot is 0, negative 4, which means if I plug in 0 for x, I better get negative 4. So if I plug in 0 for x, that'll give me a negative 2, that'll give me a negative 4 and an A. And I've got to end up with negative 4. So I end up with negative 4 is equal to 8a. And when I divide both sides by 8, I end up with a is equal to a negative 1/2. So my answer is going to be y is equal to negative 1/2 x minus 2 and x minus 4. All right, so the remainder of class, I want you to continue working on this part. Tomorrow